Okay, we're looking at exercise 15 and 16 from chapter 4, section 3. And they give us the graphs of the original function. And they want us to find the open intervals in which the function is increasing and decreasing. And they also want us to identify the function's local absolute and extreme values, if any. So I'm going to start with 15, and first thing that we're going to want to do is take a look for where would we get a change in the sign of the derivative. So where would the tangent line equal 0, or anywhere that the derivative is undefined. So here, and again, when we're given the graph, we're going to have to estimate it here, and I'm going to be estimating that they happen to fall at these nice numbers there. So what we see with the function is that from -4 to -2, our function is decreasing. Now, why am I saying that it only goes to -4? Because when we look at the endpoint here, we're not seeing an arrow. So we can go ahead and assume, since there's not an arrow there, that each of these functions is defined on that closed interval. So our next interval from -2 to 0, our function is increasing. So we're decreasing on this interval, we're increasing on this interval, then we are decreasing again from 0 all the way to +2, and then from +2 up to +4, we are increasing. And then next they ask us to go ahead and find and identify any local and absolute extreme values. So where we're getting changes in the signs of the derivative, we're going to have at least local minimums and maximums. So we do see a change in sign of the derivative at x equals -2. We do see a change in the sign of the derivative at x equals 0. We do see a change in sign of the derivative at x equals 2. And what we also have to take into consideration are our endpoints here. So absolute maximum, absolute minimum, that's going to be where they are highest and lowest on our graph. And we have an absolute maximum at x equals 4. We have an absolute minimum at x equals +2. And we are going to have a local maximum and local minimum. So at x equals -2, we're bottoming out there locally. So we have a local minimum at x equals -2, and at x equals 0, we top out for a while. So that's a local maximum right there at x equals 0. And we do have that final endpoint to consider at x equals 4. And we see that that is the highest point in the area around it. So that is also going to be a local maximum there. So don't forget about the endpoints when you're working on a closed interval there. They can be absolute maximums or minimums. They can be local maximums or minimums.